All right, this is another check of the accuracy and precision of the Fluke 8842A multimeter. What I'm doing today is I'm using a voltage reference and precision resistor network in combination to generate or produce a known current, measuring that current with the Fluke meter and seeing how it compares with the calculation. So what I've got here is that voltage reference that I've shown before, if I can get it to focus. There we go. Um, yeah, so this is a voltage reference from China. The um, the board itself uses the 8584 chip, and it can withstand up to 10 milliamps of current draw. So I'm combining that board with Caddock precision resistor network and using the 1000 ohm resistance of it that I've measured precisely. So I've got that, and I've measured the 4 different ones that I've got. I'm using this 4th one here. So that's 1000.04 ohms. That's jotted down in kilo ohms there. And then I'm just doing a simple calculation. I know the precise voltage output of the 8584 in the 5-volt mode, and also in the 7.5-volt mode, so I can calculate the current that it would produce if the voltage from this board is run precisely through that Caddock resistor. And the 5-volt mode, it calculates out at 4.9986 milliamps. And here it is on the Fluke. That last digit moves around a little bit. It's 4.996 is what I'm seeing primarily. And that, when you compare the two, is an error of 0.052%. Phenomenal. If I change this to the 7.5 volt output, I can calculate that using that same known resistance. It should produce 7.4979 milliamps, and I get on the Fluke 7.495 milliamps. That last digit jumps around a little bit. I've jotted it down in my prior test as 7.494 milliamps, and that's once again an error of 0.52%. So everything I've thrown at this Fluke meter so far shows that it's an outstanding performer, even though it's 30 years old or thereabouts. It's precise, it's accurate, and so far I'm very happy with it. So that's it. Thanks for watching.